Good afternoon, everyone. So today we'll cover NCERT section 9.4.2 with example 10 to 13 of differential equation. Okay, so the next method of solving differential equation is of the type homogeneous differential equation. So in today's class, we will learn how to recognize is the given differential equation is a homogeneous differential equation. Then we see how we can transform the given homogeneous differential equation to a type of separable variable separable method by using some substitution, and then we solve. Okay, we already learned how to solve a differential equation by using variable separable method. Okay, so what is homogeneous function? Let's suppose there is a function f x comma y, then is said to be homogeneous function of degree n if f lambda x lambda y is equal to lambda the power n f x y for any non-zero constant lambda. Okay, so if there is given a function f comma x by x comma y, and we just replace x and y by lambda x and lambda y, and we get lambda n into f x comma y for any non-zero constant lambda, then your function f x comma y is called homogeneous function of degree n. For example, there is a first function f1 x comma y is y square plus 2xy. So if we replace x and y by lambda x and lambda y respectively in the above function for any non-zero constant lambda, what we get? f1 lambda x lambda y is, so just replace x and y by lambda x and lambda y, so we get lambda square y square plus 2xy, and this y square plus 2xy again a function f1 xy, so we get lambda square f1 xy. That is, this function f1 xy is a homogeneous function of degree 2. Let's move on another example, that is f2 xy is equal to 2x minus 3y. So we apply the same process to check it is a homogeneous function or not. So just replace x and y by lambda x and lambda y, where lambda is a non-zero constant. So f2 lambda x lambda y is equal to lambda 2x minus 3y. That is, 2x minus 3y is f2xy, so you get lambda into f2xy. So this function is a homogeneous function of degree 1. Another example is f4 xy is equal to sin x plus cos y. Okay, and to check is it a homogeneous function or not, we just replace x and y by lambda x and lambda y, where lambda is any non-zero constant. So f4 lambda x lambda y, when we replace x and y by lambda x lambda, we get sin lambda x plus cos lambda y. Okay, but as we can see here, this function does not satisfy the condition of homogeneous function. We cannot get it as of the form like lambda the power n into f4 xy. Okay, so this function is not a homogeneous function. Now, a function, another definition of homogeneous function, or we can also check by this definition, is it a function is homogeneous or not, is that a function f x comma y is a homogeneous function of degree n if f x comma y is equal to x the power n g y by x, or y the power n h x by y. So let's suppose there is a function f x comma y. Just take xn as a common, and if you get a function with y by x and we name it as gx y by x, then the function is called homogeneous function. Or if we take y as a common, the power of y, and we take a function in the form of x by y, then the function is called homogeneous function. For example, let's suppose the f1 xy is y square plus 2xy. So from here we can take x square as common. So we get y square by x square plus 2y by x. We take x square as a common so that the term inside the bracket is looks like a function gy by x. As we can see, the first term is y by x whole square plus 2 into y by x. So we consider it as a function gy by x, and the value of n is there 2. So this is a homogeneous function of degree 2. Okay, so in the first definition of homogeneous example, we just replace x and y by lambda x and lambda y. And if it is on the form of lambda the power n fxy, then we say the given function is homogeneous equation with degree n. But here what we do, we just take x square x the power n as common, and we write the another part as a function gy by x. Then we say the given function is a homogeneous function of degree n. In a similar way, if we take y square as common, so y square plus 1 plus 2x by y, and we can observe here that the function inside the bracket is of the type h x by y. So the given function is a homogeneous function of degree 2. Okay. Now, a differential equation of the form dy by dx is equal to f x comma y is said to be homogeneous if f x comma y is a homogeneous function of degree 0. Okay, so if there is a differential equation of degree 1 and order 1, then we consider it as a homogeneous differential equation if the function fxy is a homogeneous function of degree 0. Okay, and to solve a homogeneous differential equation of the type dy by dx is equal to fxy is equal to z y by x, as degree is 0, so we get x the power 0, that is 1, g y by x. So to solve this type of differential homogeneous differential equation, we make the substitution y is equal to v into x. So whenever there is a homogeneous differential equation, so first task is you have to identify it, is it a homogeneous differential equation or not. Okay, and for that we have to check is it the function f x comma y is a homogeneous function of degree 0. Okay, then we transform this given homogeneous differential equation into a separable form by using the substitution y is equal to v into x. And we already know how to solve a differential equation by using variable separable method. So we just substitute y is equal to vx. So we have to write dy by dx in terms of v and x. So we differentiating y is equal to vx with respect to x, we get dy by dx is equal to v plus x into dv by dx. As when we differentiate y is equal to vx, we apply the product rule of differentiation. So at first we write v into dx by dx, differentiating second term, so we get dx by dx is 1, so we get v plus x into differentiation of v, so dv by dx, and that is the value of dy by dx. Now we have a value of y, that is vx, and dy by dx, that is v plus x dy by dx. So we just substitute the value of y and dy by dx in the equation, the original equation, that is a homogeneous differential equation, that is dy by dx is equal to fxy is equal to gy by x. So just replace y is equal to vx and dy by dx as v plus x dv by dx. So we get v plus x dv by dx is equal to zv. Why? Because y is equal to v into x. So v is equal to y by x. So we put v in place of y by x. Now rearranging the equation, we get x dv by dx is equal to zv minus v. So now apply the procedure of variable separable method. So we can separate the variable as we can separate in the separate variable separable method, that write the terms with y with dy and all the terms with x with dx. So here write the term with v with dv and all the term with x with dx. So when we separate the variable, we get dvy gv minus v is equal to dx by ex. So by using the substitution y is equal to vx, we just get a easier form, that is solved by the variable separable method. So we get dy by gv minus v is equal to dx by x. Now we integrate both sides of our equation. We get integration of dvy gv minus v is equal to integration of 1 by x dx plus c. So when we integrate, we get a general solution of the differential equation. So our equation gives general solution of the given differential equation. Dy by dx is equal to fx comma y is equal to gy by x when we replace vy y by x. So to solve a homogeneous differential equation, the first task is at first we have to check is it a given differential equation is homogeneous type or not, and for that we check is it a fxy function is a homogeneous function with degree 0, and then we use a substitution y is equal to vx so that we can apply the variable separable method to find the general solution of the differential equation. Okay. And if the differential equation is of the form dx by dy is equal to fx comma y, where x comma y is a homogeneous function of degree 0. Carefully observe here is that there is a dx by dy. In the previous one, there is a dy by dx. So if the function is of the form dx by dy is equal to fx comma y, then we use the substitution x by y is equal to v, that is x equal to vi. And we proceed further to find the general solution as described above by writing dx by dy is equal to f x comma y is equal to h x by y. That is the whole process how to solve a homogeneous differential equation. Okay, so let's do an example of homogeneous differential equation type so that we can understand how to solve a homogeneous differential equation. So that the differential equation x minus y dy by dx is equal to x plus 2y is homogeneous and solve it. So the first task is to show that this differential equation is a homogeneous differential equation, and for that we have to check the function fx comma y is a homogeneous function of degree 0 or not. Okay, and then we solve it by using a appropriate substitution according to dy by dx and dx by dy, and just apply the variable separable method procedure to find the general solution of the given differential equation. Okay, so try. So we have given differential equation, that is x minus y dy by dx is equal to x plus 2y. So the given differentiation can be expressed as dy by dx is equal to x plus 2y by x minus y. So the function fx comma y is, so when we comparing this differential equation with the form dy by dx is equal to fx comma y, the function fx comma y is x plus 2y by x minus y. Now to check, is it a function fx comma y is a homogeneous function with degree 0, we just replace x and y by lambda x and lambda y. So just write in place of x lambda x and in place of y lambda y. So we get lambda x plus 2y lambda x minus y. Lambda lambda cancel out. So we get lambda the power 0 into f x comma y. As lambda the power 0 is 1, so we can write it as, so this given function fx comma y is a homogeneous function with degree 0. So that the given differential equation is a homogeneous differential equation. Okay, so now we can apply the procedure of homogeneous differential equation to find the solution of this given differential equation. In another way, we can write dy by dx is equal to 1 plus 2y by x by 1 minus y by x, and is it of the form g y by x. So we can also check by this alternative that is it a function, is it a given differential equation, is a homogeneous or not. So because is it of the form dy by dx is equal to gy by x, so this given differential equation is a homogeneous differential equation of degree 0. Therefore, equation dy by dx is equal to x plus 2y x minus y is a homogeneous differential equation. Now, in the second step, we substitute y is equal to vx so that my given differential equation is transformed into the form in which we can separate the variable. So that by using this substitution, we just because then we can apply the variable separable method. So when we put y is equal to vx, we're differentiating both sides of the equation y is equal to vx with respect to x, we get dy by x is equal to v plus x into dv by dx. So now we have a value of dy by dx in terms of v and x, and also we can put y is equal to vx. So in a given differential equation, dy by dx is equal to x plus 2y by x minus v, just substitute the value of y and dy by dx in this given differential equation. We get v plus x dy by dx is equal to 1 plus 2v by 1 minus v. So now we can separate the variable. So we get x dy by dx is equal to 1 plus 2v by 1 minus v minus v. So we get x dy by dx is equal to v square plus v plus 1 by 1 minus v. We just simplify it and then we separate the variable. We write the terms with v with dv and all the terms with x with dx. So we get v minus 1 by v square plus v plus 1 dv is equal to minus dx by x. So after that, in the third step, we integrating both sides of the above equation to get the general solution of the differential equation. So now we have to integrate. Integration of v minus 1 by v square plus v plus 1 dv is equal to minus integration of dx by x. And we can write v minus 1 as 2v minus 2 by 2 and minus 2 as plus 1 minus 3. So we get 2v plus 1 minus 3 by 2. We just do algebraic manipulation to solve integral. And we know that integration of 1 by x dx is log x. So using this, we have 1 by 2 in place of v minus 1. We write 2v plus 1 minus 3 by 2 by v square plus v plus 1 dv is equal to integration of 1 by x is minus log mod x plus constant of integration, that is c1. Now we have to integrate this, that is integral of 2v plus 1 minus 3 by v square plus v plus 1, and we can separate the integral, that is 1 by 2 integral of 2v plus 1 by v square plus v plus 1 dv minus 3 by 2 integral of 1 by v square plus v plus 1 by into dv is equal to minus log mod x plus c1. So by this algebraic manipulation, v minus 1 is equal to 2v plus 1 minus 3 by 2, we just solve this integral. Now we have to integrate this first term and second term, and as we can see in the first term, it is of the form f dash x by fx dx, and the integral of this is log mod fx. And we can write for the second term the v square plus v plus 1 as completing square method. So we get v plus 1 by 2 whole square plus root 3 by 2 whole square. So using this, the above two formula, my integral become 1 by 2 log. Just apply this first formula, that is integral of f dash x fx dx. So we get log v square plus v plus 1 mod minus 3 by 2 integral of 1 by v plus 1 by 2 whole square plus root 3 by 2 whole square dv minus log x log mod x plus c1. And this is a standard formula, and we know that integral of 1 by a square plus x square is 1 by a tan inverse x by a. So we apply this formula to the this integral. We get 1 by 2 log mod v square plus v plus 1 minus 3 by 2 into 2 by root 3 tan inverse 2v plus 1 by root 3 is equal to minus log mod x plus c1. Okay, here the value of a is root 3 by 2. So my integral become 1 by 2 log mod v square plus v plus 1 minus 3 by 2 into 2 by root 3 tan inverse 2v plus 1 by root 3 is equal to minus log mod x plus c1. So when we simplify it, we get 1 by 2 log v square plus v plus 1 plus log x We take on the right hand side, the minus log x plus is equal to root 3 tan inverse 2b plus 1 by root 3 plus c1. And we know that the property of logarithmic is that log mod m the power n can be written as n log mod m. So for the term log mod x, we can use 1 by 2 log x square. Okay, so we just replace log mod x by 1 by 2 log x square, so that we can take 1 by 2 common, and then we apply the log property. And replacing v by y by x, we substitute v. So now we want my solution in the original variable, so we substitute replacing v by y by x. We get 1 by 2 log y square by x square plus y by x plus 1 plus 1 by 2 log x square is equal to root 3 tan inverse 2y plus x by root 3x plus c1. We know that log mod m plus log mod n is equal to log mn, log mod mn. So we apply this property on the LHS part. Just take 1 by 2 common, and then we get log y square by x square plus y by x plus 1 into x square mod is equal to root 3 tan inverse 2y plus x by root 3x plus c1. So we get log y square mod y square plus xy plus x square mod is equal to 2 root 3 tan inverse 2y plus x by root 3 into x plus 2c1. And that is your general solution of the given differential equation. That is log mod x square plus xy plus y square mod is equal to 2 root 3 tan inverse x plus 2y by root 3x plus c. Okay. So to solve a differential equation of homogeneous type, in the first step, we have to check is it a function, is a homogeneous differential equation or not. Okay. And then we use a substitution y is equal to vx to convert it into the form where we can separate the variable. And when we separate the variable, then we just integrate both sides to find the general solution of the given differential equation. Okay. Now example 11 is, so that the differential equation x cos y by x dy by dx is equal to y cos y by x plus x is homogeneous, and then solve it. Okay. So at first, use any definition of homogeneous function, and so that the function f x comma y is a homogeneous function with degree 0, so that my differential equation will become homogeneous differential equation. Then use a appropriate substitution y is equal to vx and separate the variable, and then integrate to find the general solution of the differential equation. Okay, so just try. So we have given that x cos y by x dy by dx is equal to y cos y by x plus x. So at first we rewrite this given differential equation in its standard form, that is dy by dx is equal to y cos y by x plus x. Just take x cos y by x from the left hand side to the right hand side. We get by divide x cos y by x. So when we comparing with the differential equation dy by dx is equal to f xy, we get the value of f xy is y cos y by x plus x by x cos y by x. Okay. Now we have to check is it the function f x comma y is a homogeneous function of degree 0 or not. And for that we just replacing x by lambda x and y by lambda y, we get f lambda x lambda y is equal to lambda y cos y by x plus x by lambda x cos y by x. So lambda lambda cancel out, we get lambda 0 f x comma y. That is, the function fxy is a homogeneous function of degree 0. So the given differential equation is a homogeneous differential equation. So the first part of the question is complete. Now we have to solve it. To solve the homogeneous differential equation, we use a substitution method. That is, and thus this is a homogeneous function of degree 0. So therefore, the given differential equation is a homogeneous differential equation. And to solve it, we make the substitution. That is, we take y is equal to vx. Now to get the value of dy by dx, we just differentiate y is equal to vx with respect to x. So apply the product rule of differentiation. We get dy by dx is equal to v plus x into dy by dx. At first we differentiate x, so we get v and plus x into differentiation of v, that is dv by dx. So now we have value of dy by dx and also the value of y. So we just replace it on the given differential equation. That is dy by dx is equal to y cos y by x plus x by x cos y by x. So now we will substitute the value of y and dy by dx. So we get v plus x dy by dx, v cos v plus 1 by cos v. So we write in place of y by x, v. Now we use separable method to find the solution of this differential equation. So at this step, we just separate the variable. We write the terms with v with dv and all the terms with x with dx. So for that, we get x dy dx is equal to v cos v plus 1 minus v cos v by cos v. So we get x dy dx is equal to 1 by cos v. We can rewrite this equation as cos v dv is equal to dx by x. So now we move on to integrating both sides of this equation. This is the step where we start finding the solution to the differential equation. So on integrating both sides, we get integration of cos v dv is equal to 1 by x integration of 1 by x dx. And we know that integration of cos v is sin v and integration of 1 by x dx is log mod x. So we get sin v is equal to log mod x plus log mod c. And we know that log mod m plus log mod n is equal to log mod mn. So using this property of logarithmic, we get sin v is equal to log x plus log mod c become log cx. So now we replacing v by y by x, we get the solution of the differential equation, that is sin y by x is equal to log mod cx. Okay. Let's move to another example. That is, so that the differential equation 2y e the power x by y dx plus y minus 2x e the power x by y dy is equal to 0 is homogeneous and find its particular solution. given that x equal to 0 and y is equal to 1. Okay. So in this question, we have to find a particular solution. But to find a particular solution, at first we have to find a general solution. And the procedure to find a general solution for a homogeneous differential equation is same. So at first, find the general solution of the differential equation, and then to find a particular solution, we just use the condition of x equal to 0 when y equal to 1. Okay, so just try. We have given that 2y e the power x by y dx plus y minus 2x e the power x by y dy is equal to 0. And this can be rewritten as dx by dy is equal to 2x e the power x by y minus y by 2y e the power x by y. Clearly observe here that there is a dx by dy, not dy by dx. So substitution is also changed due to dx by dy. Now we have to check, is it the function fxy, that is 2x e the power x by y minus y by 2y e the power x by y, is a homogeneous function with degree 0 or not? And for that, we replace x and y by lambda x and lambda y. So we get, when we replace x by lambda x and lambda y, we get 2 lambda x e the power lambda x by lambda y minus lambda y by 2 lambda y e the power lambda x lambda y. So lambda lambda cancel out in x by y, and we take lambda as common. So we get lambda bracket 2x e the power x by y minus y by lambda 2y e the power x by y. So lambda lambda cancel out. So we only left with lambda the power 0 f x by y. As you know, lambda the power 0 is 1. So the function f x by y, y is a homogeneous function with degree 0. So differential equation is a homogeneous differential equation. Thus, this fxy is a homogeneous function of degree 0. Therefore, the given differential equation is a homogeneous differential equation. Now to solve this homogeneous differential equation, we make the substitution. That is, x is equal to vy. Here we take x is equal to vy. Why? Due to the dx by dy. So differentiating x equal to vy with respect to y. Okay. In the previous question, we just we differentiate with respect to x. But here we differentiating x equal to vy with respect to y, so that we get the value of dx by dy. So dx by dy is equal to, apply the product rule. So at first, differentiating y with respect to y, so we get v into dy by dy, that is 1, plus y into differentiation of v with respect to y, that is y into dv by dy. That is the value of dx by dy. So now we have value of x and dx by dy. So we substitute this value in equation. Dx by dy is equal to 2x e the power x by y minus y by 2y e the power x by y. We get v plus y dv by dy is equal to 2vy e the power v minus y by 2y ev. So we just replace Substitute the value of dx by dy and we use x equal to vy. So now taking y common in RHS, we get v plus y dv by dy is equal to 2v ev minus 1 by 2ev. So now we separate the variable. So for separating, we write dy by dv by dy is equal to 2v ev minus 1 by 2ev, and take this v on the right hand side, we get minus v. So when we simplify, we get y dy by dy is equal to 2v ev minus 1 minus 2v ev by 2 e the power v. So we get y dv by dy is equal to minus 1 by 2 ev. So just separate, write the terms with v with dv and all the terms with y with dy. So we get 2 into e the power v dv is equal to minus dy by y. So now we integrating both sides to get the general solution. So when we integrate, integration of 2 ev into dv is equal to minus integration of dy by y. And we know that is integration of ev dv is equal to e the power v and integration of dx by ex is log mod x. So using this, we have 2 into e the power v is equal to minus log mod y plus c. So we get 2 into e the power v is equal to minus log mod y plus c. So we just replacing v by x by y. We get 2 into e the power x by y plus log mod y is equal to c. That is your general solution of the differential equation. But we have to find a particular solution given that x equal to 0 and y is equal to 1. So now we use this condition to find the value of this capital C, that is your arbitrary constant. And due to this arbitrary constant, we get a family of curves. So when we use this condition, we just substitute x equal to 0 and y is equal to 1 in this equation. So we get 2 into e the power 0 plus log mod 1 is equal to c, as the value of log mod 1 is 0 and e is equal to 0 is 1. So c is equal to 2. So substituting the value of c in this equation, we get a particular solution of the differential equation, that is 2 into e the power x by y plus log mod y is equal to 2. Okay. So example 13 is, so that the family of curves for which the slope of the tangent at any point xy on it is x square plus y square by 2xy is given by x square minus y square is cx. Okay, so here the given information is slope of the tangent at any point x comma y is x square plus y square by 2xy, and we have to prove that the solution, the family of curve, that is general solution for this differential equation, is x square minus y square is cx. So we know that slope of the tangent at any point on the curve is dy by dx, and it is given that it is x square plus y square by 2xy. So when we combine this both statement, we get dy by dx is equal to x square plus y square by 2xy. That is your given differential equation. Now we have to find its general solution, and we have to show that it is it x square minus y square is equal to cx. So we write it as dy by dx is equal to 1 plus y square by x square by 2y by x. We have to check, is it a function fxy is a homogeneous function of degree 0 or not, and for that we replace x by lambda x and y by lambda y. So when we replace, we get 1 plus lambda y whole square by lambda x whole square by 2 lambda y lambda x. So lambda lambda cancel out. So we get f lambda x lambda y is equal to 1 plus lambda y square by x square by 2y by x, and that is your function f xy. So we get y the power 0 into f xy. Okay. Therefore, our differential equation is a homogeneous differential equation. To solve it, we make substitution y is equal to vx. So differentiating y is equal to vx with respect to x, we get dy dx is equal to, apply the product rule, so v plus x dy dx. Now, so we get, substitute the value of dy dx and y is equal to vx in the given differential equation. So we get dv plus x dy dx is equal to 1 plus v square by 2v. So x dy dx is equal to 1 minus v square by 2v. So on separating x terms right side and v term left side, we have 2v by 1 minus v square dv is equal to dx by x. So now we just integrating both sides to get the general solution of the differential equation. So on integrating both sides, that is integration of 2v by v square minus 1 dv is equal to minus integration of 1 by x dx. And we know that integration of the type f dash x by fx dx is log mod fx. So we get log mod v square minus 1 is equal to minus log mod x plus log c1. So apply the property of logarithmic. So we get log v square minus 1 into x is equal to log c1. So we get v square minus 1 into x is equal to plus minus c1. So replacing v by y by x, we get y square by x square minus 1 into x is equal to plus minus c1. Okay, so just take the new variable c in place of plus minus c, we get x square minus y square is equal to cx. Okay, so in today's class, we will see what is an homogeneous differential equation and what is the procedure to solve a homogeneous differential equation, how we use a substitution method to transform it into a variable separable method. Okay, thank you.